Hey developers! Welcome back to Game Developer Unity. Today, we're diving into 50 crucial Unity optimization tips that will help you write better code and boost performance. Whether you're working on mobile, PC, or console, these tips will help you write efficient and optimized code. So, let's jump right in. Tip number 1: use string builder for string concatenation. Avoid using plus to join strings repeatedly. Instead, use string builder for better performance. This class is faster than the string.format method and uses less memory than concatenation with the plus operator. Tip number 2: use built-in arrays instead of lists. If you know the size of your data, use arrays instead of lists for better speed. The ArrayList and List classes have more flexibility than built-in arrays. This is because they grow when you insert more elements. However, they are slower than the built-in arrays. Tip number 3: use coroutines instead of invoke. The invoke method is a fast and convenient way to call a method in a class with a time delay. However, the method has some limitations. Invoke uses reflection in C# to find the method to call, which can be slower than calling the method directly. There are no compile time checks on the method signature. You cannot supply more parameters. An alternative method is to use coroutines. The following code shows calling coroutines through the start coroutine method. Changing from the invoke method to using coroutines provides more flexibility over the parameters that are passed to the functions that deal with animation states. Tip number 4: avoid excessive use of mathf.power. Mathf.power is slower than other arithmetic operations like multiplication or addition. If you only need to square a number, use multiplication instead. Tip number 5: minimize debug.log calls in production builds. Avoid using debug.log in production builds, as these log messages can slow down your game. You can disable them by using conditional compilation. For example, wrap your debug.log calls with hashtag if Unity editor so that they only run in the editor and not in a build. Tip number 6: avoid memory leaks with event listener and delegates. Make sure to unsubscribe event listeners or delegates when an object is destroyed to avoid memory leaks. This is especially important when you use persistent event listeners that may not be automatically removed when the object is destroyed. Tip number 7: remove empty callbacks. If your code includes empty definitions for functions, like awake, start, or update, remove them. Empty functions like awake, start, and update still get checked by Unity. If you don't need them, remove them to improve performance. Tip number 8: use compare tag instead of tag property. Use the GameObject.compareTag method instead of the GameObject.tag property. This is because the compare tag method is faster and does not allocate extra memory. Tip number 9: avoid hard-coded tag values. Instead of writing tag names directly, store them in a constant class to avoid typos. Avoid hard-coded values for tags. This is because hard-coded values restrict the scalability and robustness of your game. For example, with tag names, if you refer to the names directly by strings, you cannot easily modify them. Therefore, you are potentially exposed to spelling errors. You can improve the preceding code by implementing a special class for tags that exposes public constant strings. Tip number 10: avoid find object of type. Like GameObject.find, find object of type can be expensive as it iterates through all objects in the scene. Instead, try caching the result at start or awake and access it directly when needed. Tip number 11: reduce instantiate calls for UI elements. Instead of creating UI elements frequently, create them once and disable as needed. UI elements like buttons, sliders are often instantiated at runtime. Consider creating all UI elements in advance and simply disabling them as needed. This avoids the performance hit from frequent instantiation. Tip number 12: use transform.position instead of transform.translate. When moving objects, prefer setting transform.position directly rather than using translate, as it avoids unnecessary function calls. Tip number 13, use quaternion instead of Euler angles for rotations. When dealing with rotations, prefer quaternion over Euler angles. Euler angles can lead to gimbal lock and are more computationally expensive, especially for interpolation. Quaternion rotations are more stable and efficient, so use them when manipulating rotations in your game. Tip number 14, disable unused components. Disabling unused components, like renderer, collider, or rigid body, when they are not needed can save computational resources. For example, if an object is off-screen or inactive, you can disable its renderer and any unnecessary scripts. Tip number 15, use event-driven architecture. Instead of checking conditions frequently in update, use an event-driven approach where possible. This reduces the number of checks and ensures that code only runs when necessary. For example, use events to detect when an object enters or exits a zone instead of constantly checking distances. Tip number 16, use mathf.approximately for floating point comparisons. When comparing floating point numbers, avoid using double equal to operator, as floating point precision issues can cause false comparisons. Instead, use mathf.approximately, which compares two floats while accounting for small inaccuracies. Tip number 17, limit the use of on-draw gizmos. On-draw gizmos is useful for debugging, but it runs in the editor and can be a performance hit when used extensively. Disable or reduce its use, especially in production builds, as it can be expensive for complex calculations or many objects. Tip number 18, use async loading. Instead of loading scenes synchronously, which can freeze your game, use scenemanager.loadScene async to load scenes in the background. This helps to create a smoother user experience, especially when transitioning between large scenes, ensuring players don't encounter freezing or long load times. Tip number 19, batch UI updates and avoid constant layout changes. UI elements, like buttons, sliders, and text fields, can be expensive to update if you're constantly modifying their layout. Batch your UI updates and make sure to use the canvas group for enabling, disabling elements in large panels to reduce expensive layout recalculations. Tip number 20, use simple text rendering with Text Mesh Pro. Text Mesh Pro is far more efficient than Unity's default UI text system. It provides better memory management and advanced rendering features. If you're displaying a lot of text or updating it frequently, Text Mesh Pro can significantly improve performance. Tip number 21, use enum instead of strings for tags and identifiers. String comparisons can be slow, especially when used in tags and identifiers. To optimize performance and improve code readability, replace string literals with enums. This reduces the overhead of string comparisons and makes your code more efficient. Tip number 22, use read-only and const for immutable variables. For values that don't change, use read-only and const instead of regular variables. This allows the compiler to optimize memory usage and can improve performance. A read-only variable's value is set at runtime, while a const is determined at compile time. Tip number 23, use on-enable and on-disable for event subscription. When working with event listeners, subscribe to events in on-enable and unsubscribe in on-disable. This ensures that events are only handled when the object is active, preventing memory leaks and unnecessary checks. Tip number 24, use layer mask for optimizing raycasting. Raycasting can be expensive, especially when casting to all layers. Layer masks help optimize raycasts by filtering out unnecessary checks, ensuring the ray only collides with relevant layers. Tip number 25, use list wisely. While list incredibly useful, frequent resizing can lead to performance overhead. For example, avoid calling add in every frame. If you know the size in advance, initialize the list with a specific capacity to avoid unnecessary resizing. Tip number 26, use list.forEach instead of forEach. While forEach is readable, list.forEach can be slightly more efficient, as it avoids the enumerator that forEach creates. If you have a list of objects and need to loop through them, list.for each may offer a performance boost in some cases. Tip number 27, limit text updates. Updating UI text frequently, like displaying scores, health, can be inefficient if done every frame. Instead, update the text only when it changes or use events to notify when a change occurs. Tip number 28, use vector 3.square magnitude for distance calculations. If you only need to compare distances, use vector 3.square magnitude instead of vector 3.distance. The square root operation in vector 3.distance is computationally expensive, and square magnitude avoids it. Tip number 29, use dictionary instead of list for lookups. When you need fast lookups, a dictionary is much faster than searching through a list. If you're frequently accessing data by key, use a dictionary for better performance. Tip number 30, use dictionary instead of list for lookups. Use transform.transform direction for efficient direction calculations. When converting local directions to world space, avoid manual calculations or using transform.forward or transform.up. Instead, use transform.transform direction, which is optimized and avoids unnecessary recalculations. Tip number 31, avoid memory leaks by manually releasing references. When objects are destroyed, references may still exist elsewhere in the code, causing memory leaks. To prevent this, manually set references to null after you're done with them. Tip number 32, use coroutines for relaxed updates. If your game requires a repeated action at a specific time interval, you can try launching a coroutine in the start, callback. Launching a coroutine is an alternative to performing an action in every frame through the update, callback. This code shows an example of a coroutine. Use coroutines to do them at intervals and reduce performance load. Tip number 33, avoid using GameObject.find in every frame. Searching for objects frequently is costly. Cache the reference once in start or awake instead. Tip number 34, use onBecameVisible and onBecameInvisible. Callbacks like onBecameVisible and onBecameInvisible notify your scripts if their associated game objects become visible or invisible on screen. Turn off heavy computations when the object is not visible to save resources. Tip number 35, avoid frequent use of instantiate and destroy. Instantiating and destroying objects can be expensive. Instead, consider object pooling. When you need to create and destroy many objects, like bullets, enemies, or particles, use a pool to reuse objects rather than instantiating and destroying them every time. Tip number 36, use time.delta time correctly. When performing time-dependent actions, like movement, animation, always multiply by time.delta time to make it frame rate independent. This avoids stuttering when frame rates fluctuate. Tip number 37, limit the use of GUI in onGUI. The onGUI function runs every frame, and if you have complex UI elements, it can quickly become a performance bottleneck. To optimize, avoid putting expensive operations in onGUI, and switch to Unity's newer UI system, which uses the canvas and UI components. Tip number 38, use structs for performance-critical data. Structs are more memory efficient than classes, especially when dealing with small data types like positions or colors. Since structs are stored on the stack and are value types, they reduce memory allocation overhead and avoid triggering garbage collection. However, avoid placing structs in collections like list or dictionary, as this will cause boxing, which defeats the purpose. Tip number 39, optimize update frequency for expensive operations. Calling expensive functions every frame in update can negatively impact performance, especially when those operations don't need to run each frame. Instead, check how often an operation should occur and schedule it accordingly. Tip number 40, use onTriggerStay for continuous collision check. Continuously checking for collisions with onTriggerEnter or onCollisionEnter can result in more calls than necessary. If you need to check for continuous overlap between two colliders, use onTriggerStay instead. This reduces the number of checks by only checking each frame the object stays inside a trigger collider. Tip number 41. Leverage scriptable object for shared data. Storing shared data in individual instances can increase memory usage and hurt performance. Instead, use scriptable object to store data or configurations that can be shared across multiple objects, reducing unnecessary duplication. Scriptable object instances are memory efficient and allow you to store data that can be shared across multiple game objects without duplication, reducing memory usage. Tip number 42. Use object pool for frequently destroyed and created objects. Instantiating and destroying objects repeatedly is costly, especially for small objects that are frequently reused. Implement object pooling to reuse objects instead of constantly creating and destroying them. Pooling prevents frequent object creation and destruction, which can be slow and lead to performance spikes, especially in mobile or lower-end hardware. Tip number 43. Use time.frame count for limited interval operations. Running heavy operations every frame or at fixed intervals can be inefficient. Use time.frame count to execute operations only at specific frame intervals, such as every 60 frames, to reduce unnecessary computations. This reduces unnecessary calls, especially for actions that don't need to be executed every frame. Tip number 44. Use transform.setPosition and rotation for efficiency. Calling transform, position and transform, rotation separately can introduce additional overhead due to multiple setter calls. Instead, use transform.setPosition and rotation to update both position and rotation at once efficiently. This method internally optimizes position and rotation updates, avoiding multiple setter calls and improving performance. Tip number 45. Avoid overusing send message for inter-object communication. Send message can be inefficient because it searches for methods by name at runtime. Instead of using send message, directly call the method or use event-driven systems for communication between objects. Direct method calls or event-driven systems are faster and more predictable than using send message, which involves reflection and runtime method lookup. Tip number 46. Avoid using new inside update loops. Creating new objects, especially classes or lists, inside frequently called methods like update, generates garbage, leading to frequent garbage collection and performance hiccups. Avoid using new to create objects inside update. Pre-allocate objects if necessary or use object pooling. Minimizing object creation reduces the load on the garbage collector and improves performance, especially when done frequently. Tip number 47. Use event and delegates for decoupling. Directly checking conditions between objects in update can lead to tight coupling, which results in performance hits and less modular code. Instead, use events and delegates for a more decoupled system, allowing responsive communication without constant checks every frame. Events and delegates allow systems to be more responsive without the need to poll every frame, which reduces unnecessary operations. Tip number 48. Avoid excessive use of lerp for smooth transitions. Overusing lerp, linear interpolation, in update, or other frequently called methods can lead to unnecessary calculations, especially for simple tasks. Instead, use vector3.moveToWords for smoother, more controlled transitions. Move towards is more performance-friendly because it doesn't require the extra computation involved with interpolation, and it's better suited for many common use cases. Tip number 49. Use meaningful variable and method names. Always choose descriptive names that clearly indicate the purpose of the variable or method. Tip number 50. Write modular code with small, reusable components. Large, monolithic scripts can be hard to maintain, debug, and extend. To avoid this, break your code into smaller, more modular scripts. Each script should handle a single responsibility, like a player movement script or a weapon manager script. By breaking your code into smaller, focused components, you make it more maintainable, reduce the risk of errors, and can optimize individual sections more easily. We have covered some optimization tips to make your Unity projects more efficient. If you enjoyed this video and want to support the channel, feel free to buy me a coffee at the link in description. Also comment which tip is useful for you. It helps keep the content coming and allows me to improve and create even more awesome tutorials for you. Hit the like button and subscribe for more game development tips. See you in the next video.